What is your batch strength? How many are there in your class?
Sir, 63.
63. So what about the others? Hmm? In your other classes also, you your attendance is this.
Yes, sir,
Hmm?
22, 23, sir.
22 23 average people you attend in other classes also, right?
Yes, sir.
Okay. Hmm. Why? Why the others don't join?
Don't know, sir.
Okay.
Maybe there is a network issue.
Network issue. See, from now onwards, all of you have to depend on these online classes according to the situations. So all of you have to take care of this one. Otherwise, there is no way out. No, you have to attend the classes, and only the way you have to take the you have to attend the online classes. So there is no other way out. Hmm? Isn't it?
Yes, sir. Yes, sir.
Hmm. So 19 people. Hmm. Anyway, so let us start our today's class. Then, okay. And those who will be joining, I will definitely I will send the link what I do. Okay, means this total video lecture, uh, and after following that lecture also you will get to know. But still, uh, I expect all of you to attend the classes. Otherwise, the interactive session will not be there. Na? You may have some questions, right? So
Yes,
always
sir.
attending the online class is much more beneficial. Hmm. Yeah, 21. So let's see whether the average number of the classes gets increased in this class or not. And only two classes we have. I mean, this is the second class. So now onwards, I will take steps, okay, officially, uh, against the people who are not attending the classes, right? So you convey the message to them also. Hmm?
Okay, sir.
And your the CR is present?
Yes, sir.
Present. Who is here? I forgot the name. Pritam, na? Pritam.
Yes,
Yes,
sir.
yes. Uh, Pritam, you convey the message to your batchmates. Those who are not in the classes, we will be taking necessary actions for that. Okay, officially. Hmm.
Okay, sir.
Okay, let's start our discussion and continuation of the earlier class, the review studies class, that we are discussing about the searching. We discussed two kinds of searching. One is linear search, another is uh, binary search, right? So you know that I told you that always binary search is much more efficient. Efficient in terms of time complexity. Uh, whenever we will be studying algorithm, for any kind of algorithm, for any algorithm, we have to think for its complexity. And complexity means the time taken by the program to process. This is very, very important because time and space, these are the two resources, major resources for any software system, for any programmer, for any process. So nowadays we don't bother about the space, as I told earlier, because we can get space at very minimum cost, very minimum price. Nowadays it's not an issue, but the time, that is completely dependent on the logic of what you implement to solve the problem. So the analysis of time complexity is very, very important in this subject, data structure and algorithm. And keeping these factors in mind, we design the data structure. I told you earlier. A data structure means it is from the programmer's end, those who are uh, trying to convert the manual system in the computerized one. Right? So it depends on the programmer, developer, system developer. So always we have to uh, think to build a system which will be optimized one, which will take minimum resource, especially as far as the time complexity is concerned. We have to always think for that, and we have to design our structure of the data which will be getting as input for the process. So this is the main thing throughout the this subject. We will be touching this concept repeatedly. So I discussed the two techniques, and I think I have given you the notes also. That is the searching means sequential or linear search and binary search also. And yesterday I also the technique of binary search. What happens in linear search? We all okay. Let me open that node again. Okay, hold on. All of you can see the screen, my screen.
Yes,
Yes,
sir.
sir.
Okay, so what this is what we discussed earlier class. So here linear search, that is we are searching a particular item here, for example 88, and to search this we are comparing this value with each and every elements in the list in array, right? So if I try to analyze the time complexity of the linear search, what happens that in a broad sense, we can classify the complexity into three categories. One is the base case, second one is average case, and third one is worst case. Okay, it depends on the input, right? Because here the input is two inputs are there. One is it is the array number of elements here, this list. And second one is what is our purpose? Our purpose is to search this key, right? So the first will be we will be able to search this element. The complexity will be minimum. Time will be taken less, right? So if this key we get in the first element here instead of 1, if had it been 88 placed over there, so only one comparison is sufficient, right? So only one iteration would be needed for this one. This is the best case. If 88 is placed here in the last element, so this number of comparisons we have to go through. So this is the worst case, and the average case is if this one, if the element is placed somewhere in the middle of the middle zone of the list. So that will be the average case. Got it? All of you are understanding? Hello, please respond.
Yes, sir.
Any difficulty to understand for you what I said just now?
No, sir.
It's clear to all of you?
Yes,
All
Yes,
sir.
of
sir.
you,
Yes, sir.
please respond. Let me repeat once again. The complexity is of three types. One is best one, another is worst one, another is third the average one. The best case, if we find the key in the first position or second position somewhere, okay, means somewhere at the means what to say, the beginning of the list, it will be the best case. Time will be required very minimum, right? So this is the best case. If the key is placed somewhere at the end of the list, then it will be an worst case. And if the element is placed somewhere in between, somewhere in the mid place of the list, it will be an average one, right? Here we can say this average one. So whatever it is, always we analyze the worst case, right? Means the maximum time taken by the program, right? So this maximum time here, see how many, means for, let's say, for 87, we are trying to search this 87. How many comparisons will be needed? 1, 2, always 87 will be compared with 1, then 100, then 2, then 66, then 55, this way, this way, this way. So number of comparisons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means number of comparisons are approximately equal to the number of elements of the list is the worst case, right? So if the array is the array size of a dimension n, if we, whenever we will be calculating in general mathematical formula, we have to devise a formula, right? So how to devise one? Let's say the array size is n, right? Okay, got it. Here
Yes, sir.
n is this is a. If it is n, then how many comparisons are required? N number of comparisons are required approximately, right?
Yes, sir.
First comparison, third, fourth, fifth, sixth. In this way, the number of elements present in the list, that will be the number of comparisons, and that will be your complexity. If for say and takes one, one microsecond comparison, number of elements takes in microseconds for the processor, right? So and complexity is of n. We write O. It's a function of n, order of n. So linear search complexity ever was complex linear search is n.
Yes, sir.
Now to the second one, the binary search must be sorted. The first condition. After the condition is satisfied, what we are doing, we are always making the array half of it because it is sorted, and we are reaching to that particular key. If the key is present, making the array half in each and every iteration, right? Here, this is 19 is placed over there, so comparing this 19 with that this middle, and then we discard the second iteration. We are considering this part in the second iteration. After considering this part, again we are trying to find out the middle element, comparing the mid value with the key to be searched. Right side, then we will be discarding the left part. So considering this part, and again we are trying to find out the middle element value compared with the key to be right. In this way, we can eventually hit the element if the element is present. So always
Yes, sir.
we are cutting the array by half, right? So now our purpose will be to formulate the time complex. So now the material here, this one I prepared. time complexity of binary search. Very important. Let's say this is the array, this element. Select the mid element 60, you have to select. And now we are here. The twist the array, so we will be discarding the left part. Now this array will be considered, right? Here it is written. Now in iteration 2, the whatever we have discussed this way. Okay, this example is different, but simply this one, right? This way. Here we are calculating this 56 mid element and comparing this with the 23, and it is less than discarding this right part, and we will be 38. The element 23, so this one. Now ultimately we can hit the element, right? So this way. Now if we formulate complexity, time complexity of the iteration, so first iteration length of array is 10. In second iteration, what we are doing, we are cutting the array by half, right? So now
Yes.
again this array n by 2 will be splitted again by half, so n
Yes,
by,
sir.
right? So
Yes, sir.
n by 2 by 2 means n by 2 square, right?
Yes, sir.
Contain to some k, therefore after k iterations this index will be changed, right?
Yes. Yes, sir.
Into n by 2 to the power k will be
Hmm.
there. So this number of comparisons is required. Okay.
Hmm.
Now this n, this is the mathematics. In mathematics you have studied the probability. The probability to get the element is 1, means it is if it hit, if it is found, then probability will be 1. Such if we hit a particular means particular event, right? The probability is 1. So n by 2 to k, we hit the probability n by k is the 1, right? N. What is the value of n? You can say. Now we have to search the value of k. So now is right. This one, got it? Because k number of iterations is required to find out the element. So n is to the power k. So what will be the value of k? It will be log n this 2 to the power k log n. We are simplifying this one, taking log in both sides. So ultimately value of k will be log n to the base 2. Got it? From these equations, if we find out the value of k, this will be log n to the base 2. Got it?
Yes, sir.
Any problem? It's simple.
No, sir.
Okay.
No, sir.
Got it, na?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So now, if we want to compare the time complexity of linear search and binary search. Let's say value of n is 1024, means 1024 number of elements are there. For example, I'm gonna say for example, right? In value of 1024,
Hmm.
okay. In linear search, the worst case complexity, then how many number of comparisons will be required? That number 1024, right?
Log of
N
log of
is
one.
the complexity is n. So value of a, since the value of n is 1024, then 1024 number of competitions will be required in case of search. But here friends, this is 24, right? Your 10 is 1024, na?
Yes,
Hello?
sir. K equal to 10.
Yeah. So K is 10. So see that difference. Over there, linear square number of iterations requires 1024 times here. Okay. So it is 100 times better. The binary search is 100 times better in terms of complexity. So this is the mathematical, you can prove that why the binary search is much more efficient than linear search. This is a bit of mathematics, so I will be giving you the notes. You can, this will be deriving. If you are asked to derive the time complexity of binary search, or if you are asked to compare the time complexity between binary search and linear search, you have to just write these mathematical derivation. Got it? Very easy. So
Yes, sir.
complexity means worst case complexity always we consider. The worst case complexity of binary search is log n to the base 2. Right? So far, any questions you have? Ask me.
No, sir.
Ask me. Stop presentation. We are presenting. I have to stop the presentation. Right. Any question?
Up to that, no, sir.
No, sir.
Okay. So now we will be discussing. This is the first part of the your syllabus. Okay, this is the complexity analysis. Okay, what is data structure? What is the necessity of data structure, binary search, and linear search? First part of your syllabus. Now we will be discussing some prerequisite about some prerequisite knowledge to get the implications of this subject. That is, since we are every day, always we are talking about the structure, I will suggest you to revise the chapter structure in C, right? So I think all of you have studied structure. So again, I will be showing you an example in C how we write a structure just to you'll be able to recall this one, right? Okay.
Okay, sir.
Amit
Okay, sir.
Mondol. Amit, okay, it's outside of it. Anyways, so this is the way whatever you will be studying in algorithm, we have to analyze the complexity of the algorithm without finding out the complexity. Your product, your whatever you will be developed in real life will be of no use, because ultimately it has to be sellable one. If it takes maximum resource of the system, then your product will not be of any use. So you have to eventually your product has to be the faster one, right? So that it takes minimum time to process, right? Anyways, so now I will be showing you structure. Okay, fine. It's present. I'm presenting. Okay. So let me take an example. Uh, mm, hmm, hmm, this one. This complexity. Texture. Anyways, just a minute. Wait for a minute. 33 programs. Mr. Mr. Program 1, Program 2. Just a minute. Structure. This one. Structure 2. Open with that. This is a program. So I will be executing this program. Though the practical is not there in your syllabus, but what I told you, I will be time to time I will be showing you some practical. Okay, means this program. I will be running some practical programs so that you can feel better, right? You will
Okay, sir.
attached with the subject. Uh, let's see. Let's see. Let's see. Let's see. FC++ is there. I think I have to install this one. Just let me check whether the system is installed with the thing. It's not installed. No. Okay. C is not there. I think in the system. P is not there. Okay, I will be yeah, running the program in the next class because this C software is not installed right now in my system. Once I'll be installing this one, I'll be showing you after executing this one. But let us just discuss about the code. All of you can view this one. Is the font is visible for
Sir,
you?
no, sir. No, sir.
Okay, zoom in. Just a minute. View. Zoom in. Control plus. Now it is visible.
Yes, sir.
All of you can see the code.
Yes, sir.
Yes, sir.
See, this is an example of structure. You have already studied or written the code from in structure in your CS201. So let me uh, revise this one once again. So here we have defined a structure of students, right? So how many parameters maybe there means how this is called structure element, right? This structure name, and after that we will be defining a structure variable. So this is the structure we have defined according to the requirement. So a student, how many parameters may be there for a student? His roll number, his or her roll number, year, name, department, and course, right? Okay. So taking these elements, for example, I have designed a structure for student, right? So this is the way to write to define a structure. Struct is the keyword. Struct stud is our name. I have given the name. You can give any another name, right? So stud, I have given the name stud. So actually, this structure defines a stud structure having the structure member or element this, right? So as you know that a structure may contain heterogeneous element, it may contain int or carry nuance, right? So now my purpose is to handle with the three number of student, right? So that's why I have defined an array of structure. Array of structure means as here struct stud, and this is the variable s. So s is the variable of stud type structure. Got it?
Yes, sir.
If I take a single variable, so I would have written struct stud s. Here I have taken three number of students. That's why definitely I have to take an array of three elements, right? Size. So struct stud s3. So here s is an array ops to type structure. Technically, we will be calling the statement in this way, right? So S is an array of to type structure, and the size of the array is 3. So now our purpose is to take the input for each and every student and display the same. Means here we are handling the 3 records basically. Right? This is one record, na? S1 the record of a student, S2 record of a second student, S3 record of a third student. Now since the array element starts with array index starts with 0, so it will not be 1, 2, 3. Rather it will be 0, 1, 2. The way we handle array. Could you recall this one?
Yes, sir.
Yes. So we have taken
Yes,
a
sir.
loop. Definitely we have to take a loop, and the number of iterations will be 3. It will start from 0 and 0, 1, 2. Whenever that I, the value of the I will be equal to 3, the control will come out of the loop, right? And high plus plus. So I 0, what we are doing, printf, we are displaying a message to the video in our screen that I ask the user to enter the name. So name, and how to take name. Now the moment you enter the name, so it is a string array of characters, na, you string char name, right? Hello, char
Yes,
name,
sir.
maximum character of the student will have must be 80. I have
80.
right. So here what is the function to get a string? Get s. This also you have studied when you studied string. Get s to take the string as input. Get is si dot name. Had it been a single variable s, then we could have written get as s dot name. Since it is of the for the first student means first student is indexed by 0. I0 is the first student, right?
Yes,
So
sir.
I dot name here from in the first iteration it will be s0. I value of the I will be replaced by 0. So s0 dot name. That is name of the first student will be stored here, right? Then second one department, this way get is department, then course get is si dot course, printf a roll number and year is of integer type, that's why it is scanf. I have taken scanf, I have used scanf function, scanf %d, then amper the way you take the input. Na? Have you forgot all this, or you can recall? How,
No, sir. Recall, sir.
how do you
We can
scan it?
recall it, sir.
Huh?
No, sir, I'm
You
not
are recalling,
observing.
sir.
We can recall it.
Yeah, that's why I'm telling you, just you just take any book of C and just 3 chapters you just study at your home. One is structure, array, and function. These 3 chapters are very, very important for you if you want to write the code, if you want to get the actual implication of the subject. Otherwise, if you only study the theoretical part, na, you will not get interested, because in real life, if you join industry, ultimately you have to write code first, right? When you will be experienced one, then from that software developer you will be promoted to any other, when where you won't have to write any code, right? But initially, as a junior software developer, if you get chance at industry, you're supposed to be junior software developer. So the maximum possibility to get the opportunity to write the code as a coder, right? So you have to write with code, and crack campus interview, also to get a job in campus interview, you have to have a bit of knowledge on C, because this is in your syllabus according to the university, right? So they will be asking some questions on C also. There is a possibility. So anyways, so this is the way to take input of integer type scanf, and this is called format specifier. Since it is an integer type, that's why %d. Had it been float, we could have written %a, instead of %d, right? So it is integer roll number and year. So 2 variables we have taken from the keyboard, and ampersand si dot roll dot. You can see here, to access each and every member of the structure, we are using an operator, dot operator. So dot operator is used to access the member of the structure. Here, these are the members. We are accessing the members using the structure variable. SI is the structure variable, right? And department, course, year, role, and this year. Okay, these are the your structure member, right? So using dot operator, we will be accessing. This is the convention of C, right? But don't discard this one. This is an function f plus. It flushes out the input memory of the device. So no need to bother about this one. It helps to take the input smoothly from the keyboard. Sometimes we get problem from the system. So to flush out the input memory, we use a flush. So this is an extra function. You don't have to take so much headache with this a flush stdio. Okay. So this taking input we have completed, right? There will be 3 number of iterations. S0 will be for the first student, S1 will be for the second student, S2 will be for the third student, right? Got it? Now after that, here my purpose is to search up the students who belong to a particular year. Let's say here 2 students from second year and 1 student from third year. If the user enters 3 or third year, right? Here we have taken third year as what? This SI dot year. So only 1 student will be of third year. Now printf means this is for to display a message to the user that which data record of which year you want to search. So if say for example someone has typed 3 from the keyboard. So if there is a student in third year, so the records of that student of those number of students will be displayed. So now we are searching how many students are there from third year. So how we'll search? Only one member is there, that indicates the year. Here I have taken input which year, this way SI dot year, right? Got it? So we are searching and see this year what we are means what the user will be entered from the keyboard, that number of that variable will be taken by this YR variable. YR is another variable we have taken here. This YR variable is to store the input from the user for year, right? Now we are checking whether this SI dot year matches with YR or not. For example, if S means third year is there, and if an user supplies 3, then it will be matched, and the name of that particular student will be there, right? Means how many students are from here from the third year, or their names will be displayed. Or if it is second year, according to the choice from the user. So according to the number of year, the records will be displayed, their names will be displayed. Okay, this is an example how to take the input to a structure, array of structure, and how to search a particular record from that array of structure. Got it? The next day I will execute this program in C, so it will be much more better for you to feel, right? Got it? So far any
Okay.
to understand?
Yes, sir.
Huh?
Yes, sir.
What
Yes, sir.
what problem? Yes or not, Mane? Do you have any question? You can ask me. Do you have any questions? Any of you?
No, sir.
No, sir.
I will be sending this note to your classroom, and if you have any query, you can ask me in the next class. And in the next class also, I will be executing this program under C, right? So it will be much more clear for you. Got it? So the 3 chapters I told you, you have to revise at your home. Number 1, that is array. Second one, the structure, and the third one is for function. This is not required for your theoretical subject, right? Because the programming is not there in your syllabus. But if you really want to learn something, uh, you have to write code, right? And this is the objective for the university, to keep this subject as an optional one, so that you can get a scope to get into IT industry also. Got it?
Yes, sir.
Have you felt the importance for this subject to be included in your syllabus, so that there remains a scope for you also, theoretical guys, to get into IT industry? And whenever you be joining in IT industry, you have to write code. So at least a language, means definitely C language, because all the students starts with C language, is mandatory for you, right? Otherwise, there will be their requirement will not be fulfilled to get you recruited. Clear? So
Okay, sir.
that's all for today's session. In the next class, I will be executing this program, and I will move to the next topic according to your syllabus. Okay? And
Okay, sir.
to other batchmates to join the class, not in my class only, to join all the classes of all faculties, because your average attendance, what you said, this 22, is not good, it's very poor, right? Okay, so
Okay, sir.
let's conclude this today's session. Okay.
Okay, sir.
Okay, sir.
Okay. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Hmm.
Thank you, sir.
Hmm.